Seventh graders, let's go ahead and knock out 6.2. I got all the options. It says find the sample space of the experiment rolling a number q. If I roll a number q, it could either land on 1, 2, 3, 4, 5, or 6. That's all the sample space for that particular problem. Number 3 says flipping a coin 5 times. If I flip the coin 5 times using the fundamental rule, that means I'm going to take 2 times itself. Let's see. I'm sorry, I should be not here. 2. Remember, this is a coin, so there's 2 sides. Times itself 5 times. I'm just going to erase this top part. That was kind of a blooper there. And if I do that, I realize, well, that's multiplying 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. So there's going to be 32 possible outcomes here. The outcomes are going to be, well, things like, well, 5 times heads, 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 heads. There could be 5 heads in a row. There could be 5 tails in a row. There could be 4 heads and 1 tail, 3 heads and 1 tail, and then another head. You see all the different possibilities here of heads and tails. But if you count them up, you'll see that there's actually 32 possible here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, just like we said. Let's go to number 5. It says the vertices of the figure are given. Rotate the figure as described. Find the coordinates of each image. It says that I've got H is 2 and 1, I is 3 and 3, J is 5 and negative 4, and K is 3 and negative 2. You might think we need to graph all this, but we don't, because it tells us we're taking 270 degrees counterclockwise about the origin, which we could also say is 90 degrees clockwise. When we do this, what we're going to do is take the y and turn it to the x, and then x and turn it to the y. But when the x turns to the y, it will become a negative number. So just like I said, h prime is going to be 1 is x now, and then 2 will become a negative 2, right? The x will become negative and become a y. The y will become the x. So this would be 3 is y and negative 3 as y, and then 3 is x. This would be negative 4 is x and negative 5 is y. This would be negative 2 is x and negative 3 is x. All right. Let's go to number 7. It says, you roll a number cube, describe the likelihood of the event, rolling a number greater than 2. Well, there's 3, 4, 5, and 6 that these numbers can be. And let's see, that would make 4 numbers out of 6, which is equal to 2/3. So if I turn this 2 divided by 3, I would get 6.6 repeating. And that's going to give me, as a decimal, 66.6 repeating. Well, if we round that up, since 6 is bigger than 5, that would be a 7. So my answer should be 66.7%. And it is 66.7% likely. Number 9 says rolling a number greater than 3 twice. Let's remember that if you're rolling a number greater than 3 once, is 4, 5, and 6. So that's 3 out of 6, which is equal to 1/2. But then it says twice, which means we're going to have to take 1/2, right, and multiply it to 1/2. It's almost like 1/2 squared, right? Or to the power of 2, excuse me. So 1/2 times 1/2. Let's get back over here. Well, 1 times 1 is 1. and 2 times 2 is 4. So that means there's a 1/4 chance, which is equal to 25% chance. So let's see how we did. Should be a 25% chance. If it's 1/4 equals a 25% chance, unlikely. All right, number 11 says you randomly choose one of the cards, you replace the card and choose another card. Find the probability of the event. You choose a 3 and a jack. Okay, the 3 and the jack. So what's the probability that I'll get the 3 and then the jack? Well, remember, getting a 3 the first time is going to be, well, 1, 2, 3, 4, 5, 6. That's a 1 out of 6 chance, right? So that's 1 out of 6. And the jack is also going to be for the 3, and then, so that's going to be, whew, 6, I guess it's like 1 out of 36 chance. This is saying 1 out of 18, which is 5.6. Let's see where they got this from. We know that we're trying to get one card out of 6. So you choose a 3 and a jack. So your options are going to be 10, well, 3, 10, 3, and this is going to be 1 out of, let's see, 1 out of 6. And then again, to get the jack, well, you know what, hold on, you choose a 3 and a jack. It never actually says that you choose a 3 and then a jack, right? You choose 3 and a jack. So that means you could get a jack and a 3. So you're going to have to take that 36 and divide it by 2. And that's where they got the 18, right? Because you could pick 3 and a jack, you could pick jack and a 3. So there's 2 out of 36, and 2 out of 36. So you can see we can divide the top and bottom by 2. That's going to give us 1 out of 18, which is 5.6%. Number 13 says you choose 2 odd number cards. 2 odd number cards. Well, let's see. The odd number cards here are the aces and the 3. I guess if you wanted to say the jack. So 2 odd number cards, they're saying it's 1 out of 36. 2 odd number cards. Well, I know the ace and this ace and this 3 are odd numbers, even if you don't want to call the jack. What we have to figure out is to choose 2 odd number cards. How would you end up getting that? After looking at this closely, we're just going to go ahead and mark number 13 correct for everybody. This answer is wrong. I guess they're assuming that aces are not odd numbers. We know that ace represents 1. I guess if they're just talking about odd numbers and nothing else, that would be a 3, since ace really isn't a number 1, but we look at it as 1 in the deck. I would have assumed that the aces and the 3s were all odd numbers, which would have put this at 25%. But because they're looking at it just as numbers itself, they're saying there's a 1 in 6 chance that we're going to go ahead and pull that 3. And the next will be a 1 in 6 chance again, pulling another 3. When we multiply these to each other, it's going to get a 1 out of 36. But I know that everybody looks at aces as odd. Some of you might have even said the jack was odd. But they're just talking about odd numbers. So it's a very deceiving question. I'm removing number 13. Number 15, you choose an even numbered card, then an odd numbered card. All right, an even numbered card is going to be basically a 10, right? Because you're talking even numbers, and an 8. And then an odd numbered card. So the even numbers, if we're doing it the way that they were explaining it, we're going to be 2 out of 6. And we know that 2 out of 6 is really 1 out of 3. And then to pull an odd numbered card, well, if they really are just looking at the 3 as odd number, that's going to be 1 out of 6. Now you got 1 times 1 is 1, and 3 times 6 is 18. And that's where they got this answer here, number 15. All right. You know, I, I hate doing this, but I'm going to go ahead and put number 13 back on there. I mean, I'm on the video showing you how to do it, so nobody should get it wrong. Um, so I'm just going to say number 13 and 15 are back in. I don't like the questions, but at least I'm here explaining how they went ahead and worked it out. Let's move on. Oh, sorry. Now we've got number 17. Predict the number of times the event will occur when you randomly choose a marble 350 times and replace the marble each time. Okay, so it says you choose a green marble, right? Predict the number of times the event will occur when you randomly choose a marble 350 times and replace the marble each time. Says you choose a green marble. Doesn't really tell me um, how many green marbles are in there. So predict the number of times the event will occur when you randomly choose a marble 350 times and replace the marble each time. Without knowing how many marbles are in there, this is kind of difficult. I'm going to see if there's any missing information. As I thought, the picture here with the marbles was missing, so I put it in now. Remember, this is choosing a green marble. Well, we have 1 green marble out of 1, 2, 3, 4, 5, 6, 7 marbles. So that's a 1 out of 7 chance, right? And predict the number of times the event will occur when you randomly choose a marble 350 times and replace the marble each time you choose a green marble. They're saying 50 times. If you randomly choose a marble 350 times, how many times? Well, think about that. 350 divided by 7 marbles will give you 50. So that's going to be 50 times. 19 says you choose a blue marble. There's 2 blue marbles. So this time, that 350, well, think about it. If one was 50, right, then 2 of them is going to be 100. So 19 would be 100. Okay. For 21, your teacher creates a spinner that's shown here. Their class spins a spinner each day. Out of 180 spins, how many times do you expect the spinner to spin math games? So we got 1 block here, equal amount of space to the rest of these. And they're saying, how many times do you expect the spinner to pick math? Well, there's 1, 2, 3, 4, 5, 6 possible things that could land on. If you have 180 divided by 6 will be 30. So I would say probably 30 times. Seem to be missing something here. Let me get this fixed. All right. So I had to fix that. And it was correct 30 times. And 30 times, that's 1 out of 6 times. Times, right? 1 out of 6 times. Times 180. That's 180 divided by 6. It says extra homework problems. For the extra homework problem, there's two of these sections here. So that's 2 out of 6. So 180 times 2 out of 6 will give me 60 times. Okay, let's go to number 23. It says combination lock has 3 wheels, each number from 0 to 9. You try to guess the combination by writing 5 different numbers from 0 to 999 on a piece of paper and find the probability that the correct combination is written on the paper. So to find that probability, the correct number is written on that paper. Well, there are 1,000 possible combinations, right? With 5 tries, you would guess 5 out of 1,000 possibilities. So the probability of getting the correct combination is 5 over 1,000. And that could be 0.5%. Number 12, or number 25, excuse me, says, put this over here. Your friend suggests the following methods to determine who will buy soft drinks at a gas station. Method 1, you spin the spinner shown twice. I see no spinner, so I'm going to have to find. All right, I found the spinner here. It said method 1, you spin the spinner shown twice. If both spins are yellow, you buy the soft drink. If both spins are purple, your friend will buy the soft drink. If the spins are different colors, repeat the process. Method 2, you roll 2 number cubes. If both are greater than 2, you will buy the soft drink. If both numbers are less than or equal to 2, your friend will buy the soft drink. You roll again. If you roll again, if you roll 1 number greater than 2 and 1 number less than 2. Which method do you prefer? Well, in method 1, after any 2 spins, the probability of you buying this drink is 4 out of 25, which is 16%. Using method 2, after any 2 rolls, the probability you buy the soft drink is 4 out of 9, which is 44%. Describe how you can alter both methods so that you and your friends can equally turn. You and your friend are equally likely to buy the soft drink. Well, change the spinner in method 1 to have the same number of equal side sections that are yellow and purple. So in other words, I might, since there's 1, 2, 3, 4, 5, I might change one of these purple ones to be half orange. That would give me 2 and a half that were purple and the rest were yellow. If they're both less than equal, if they are both less than or equal to 3, your friend will buy the soft drink. Otherwise, roll again. All right, guys, that's it for me. Looks like the rest is on you. See you in class for